The overall thing that you're going to do is to do lateral movement throughout a cloud project. And you're going to do lateral movement that combines some of the cloud native things that we've been looking at and legacy things that we've been looking at to basically compromise a project. So yeah, it's done mostly via legacy techniques. So the first thing you get are some credentials, which you see in the Google Doc. And these credentials will allow you to list buckets in the project. And so you can see some particular buckets are accessible. And one of the things in the S3 bucket, when you run AWS services, they generate a lot of data, like log files. And before AWS had more of a native solution for storing these log files, like CloudTrail, people would run their legacy infrastructure and then stream the logs into an S3 bucket. And then what you would do is you would run things like Athena. So you did this in Aws2, the Defender path, where you would just say, you know what, I need to be able to query this particular log file. And so Athena allows you to point the tool to a flat log file in an S3 bucket and allow you to query it. So this is actually common to store log files in buckets. And one of the things that listing the S3 bucket does for you is it lets you get at the URL, the log files for a particular, what this is a load balancer. So I haven't really talked about this much, but in the cloud class, we talk about content distribution networks, and we talk about application load balancers. And what it is a load balancer is a reverse proxy. It's presenting the world a single IP address, but then it's going to proxy your connection to a whole server farm on the back end that will actually handle your request. And that's what load balancers are really good at. I mean, there's like hardware-based load balancing that allows you to get really high throughput of connections. And you're basically tricking the user. It's a virtual server is effectively what they implement. And so one of the things that you can instantiate this on AWS, you can instantiate this on Google Cloud, but you would like to be able to log all the interactions with this load balancer. And that's what this is demonstrating. Oh, this elastic load balancer, which is the terminology in AWS for one of these things. It's an elastic load balancer for some kind of site. And this site, the logs are stored in this bucket. And as part of the log file, it exfiltrates this secret path to an admin route on the backend web application. So this secret route, and this is very similar to your Thunder CTF exercises, allows you to run remote commands, right? Like this is security through obscurity, which never works, but people try anyway. So this is a route that is leaked. It's meant to be hidden. It's got this crazy naming thing, and the admin thinks just because nobody can guess that URL, nobody can get it. And then because you have exfiltrated the log file that has this URL in it, then someone can access it. And it turns out this route allows you to run arbitrary commands on the site. And that's intended behavior. It's like an admin console. And one of the commands that you'll run is to add an SSH key to the site so that you can SSH into it. Now for this is going to be optional for you. When you get to this step, this is kind of painful. Well, it's hard to get right, I should say. And so what I'm going to do is I'm going to instantiate the SSH key for you. Well, I'm going to show you this live, and then I'm going to cut and paste that SSH key into the Google Doc. And then you can actually, copy and paste that into a file, change the permissions, and then do the SSHing directly yourself. So that's what I'm hoping to do today. But if you really are adventurous, you can actually go and run the commands that are in the code lab. I'm just going to show you this directly. And then when you do this, you can SSH into this EC2 instance that's running the admin site, and you can get access to the role that it has for operating on the cloud project. Now, as part of this role, what you can do is you can list the metadata of the EC2 instance. And as part of the metadata, because this role, because this EC2 instance needs to talk to a backend database, so an Rds database, for example, I think it's a Postgres database on the back end, you'll see that it's been configured in the metadata has as part of its configuration, the database credentials that you're gonna retrieve information from this database that's hidden otherwise. Now you can basically use those credentials directly to get into the database and solve the level, but we're gonna do something more, just more interesting. So that's one path. The path we're going to do is with this role also allows you command line access to a different storage bucket. And this storage bucket has secrets stored in it. So the first one is like elastic load balancing bucket, and we're going to look at the log files. The second one is a secret storage bucket, and anything that's got secret in its name means that it's got good stuff in it. And so that's what this thing has. And when you access this thing, you'll see that there are some database credentials in a file. And then with those database credentials, then you're going to use this access to basically connect into the Rds database and dump the I think there's some kind of secret, forget what it is. But there is some secret that gets dumped out. Okay, so that's the level. And then this is an interactive SQL shell that you can use to dump the database entries, and we'll give you that in this lab. Okay, so that's the lab. I am going to now bring this thing up. I don't need that anymore. So here I am, I'm White Flipper. Let me resize this. I only need that. All right. So I've got the AWS CLI configured. So this is just on a Linux lab machine. So then I'm going to do AWS configure. And I think, well, this is actually in the code lab. This is the first thing is setting up the profile. The access key is here. Secret access key is here. US East 1. And now I have Lara's access key. So what I'm going to do next is I'm going to do the AWS S3 Ls. So get this first thing done. And you can see this has got, you know, a log bucket, a key store bucket. This is a different way of solving the level that we're not going to do. But these are the two buckets. And so you can try and do an AWS S3 Ls. And then you can actually see, well, I like that secret bucket. I just want to list that thing. And then you'll be like, oh, no, I can't get it because I don't have the right permissions. But, well, maybe this log bucket is something I can actually access. So maybe I'll copy and paste that thing. Oops. Wow, there's some network connections here, issues. And you can see, I actually see that there is some kind of log directory in this. So I do have access to this particular bucket. And so one of the things I want to do is, well, in the lab, they ask you to do a recursive listing. So that's what I'm going to do next. And then you can see in this directory, CBLB logs, AWS logs, there's all sorts of entries here for different IP addresses. And I would imagine these are the IP addresses of the backend thing. The Google Doc and credentials should work. Okay. So yeah, that's basically what's happening. These are the log files in the bucket that basically have for each backend file or backend server in the server farm, it's got a separate log file. So I'm just gonna copy it over, and that's what the next thing is. And it uses the Aws S3 Sync command, which is kind of like rsync in if you used rsync, it's a Unix command, Linux command. Rsync takes over an entire directory tree and copies it into another one. It's kind of similar to a cp -r minus rp. So it tries to take over all of the modified dates and copy created on dates. It's just a one-for-one copy. So that's what I'm going to do next. Actually, I don't want to retype that bucket name. So I'm going to do an Aws3 Sync. And I am going to say that's the bucket that I want to sync over. And I want to sync it over into the current directory. And then what I want to do is -- profile. If I could type. And then you'll see this thing will copy all of this stuff over. And then it completes it. And if you do an ls, you can see the cglb logs are here. So let me go into that cglb logs, and you can see there's, well, you can see that this thing is just a bunch of directories. And then you see elastic load balancing. And you see it's US East 1. Oh yeah, you have to configure it with the, yeah, you have to actually configure the profile correctly and then attach the profile when you're doing the instances. And so you can see there are some logs here. 2019, 2021. This is from today. And you have all of these things. These things are compressed. So you had a bunch of log files. Let me just take one of these things and put it in the current directory. So you can use zcat on this thing. And one of the things that it'll do is if you zcat that thing, it will basically zcat is uncompress the file and then do a cat. So you could actually do the regular. So if you see this gzip, the gzip extension, this is the one huge file name. You could just do a gun zip on it if you would like. And then you can get the this is the log file that this is the log file it returns. So sorry. So then now this is the plain text version of that gzip file. So you can just do a cat on this thing. And then you can see this is one of the accesses. And if you look at one of the access, you can see there's this crazy HTML file in here. And that's the secret admin route to this thing. Yeah. So this gets you to this thing where you found the admin, you found the URL, this secret admin URL in the log files of this load balancer bucket, the log bucket for the load balancer. So that's where we're at now. Yeah, if you're getting access denied, make sure you have the right bucket because you're not doing the secret bucket yet. the secret bucket, and this is what I showed. The secret bucket you don't have access to initially, but you do have access to the logs bucket, and then the logs bucket is what you're, yeah. So that's where we're at now. In the code lab, I have you grep. So the grep is not going to work unless you do the zcat in the. So I'm going to show you this. The grep isn't going to work unless you do the zcat first. But I wanted to show you on this thing. If you go into this, if you go into the 2019 version of this, you can see there's just a single log file, and that's what the grep command was intending for you to do. Probably should have been more clear. And then from that grep, you can see right here. Sorry, it's a lot of junk in here. You can see that that secret URL there as well. All right. One of the things with the Lara profile is that you can, so now you know there's some kind of secret admin route that this load balancer is basically proxying connections for. So then you need to find out, well, what's the IP address of the load balancer? What are people using to get access to this secret admin site? And that's what you can go back and do this on the AWS CLI. So here I am back in the AWS CLI. I don't need the log files anymore, so I'm going to delete them. So the AWS command for dealing with the Elastic Load Balancer is ELB, but then because there are different versions of this, we're using version 2. So it's similar to the AWS S3, AWS ELB. And this is describe load balancers, -- profile Lara. And you'll see this command will show you the load balancer that's being used to proxy on into the admin site. So let this thing run. Oh, finally. So you see these. So one of the things with load balancers is that typically you would want an instance in 2 different availability zones, because availability zones in the cloud have independent power sources, independent networks. They're meant to be isolated from each other so that you can treat them as having independent failures. And so you'll see that the availability zones that this load balancer is attached to span both US East 1B and US East 1A. So yeah, for the zcat command, you just zcat .gz file, and then it will basically do the gunzip and the cat at the same time. So that's that command I use. But you can just use gunzip the gz file and then just do a cat. You do those separately. Yeah. Yeah, after the cat, you're just looking for the HTML file that shows up in the load balancing logs, because it's going to proxy into some route on the backend server. Yeah. Yeah, they're all the same. They all have got this route. I mean, it's meant for you to find this HTML file. So I think every single entry has got this URL in it. They're not trying to trick you. They're just saying that this is just a scenario that, if it was a dedicated hacker and there were 100,000 different URLs in that log, eventually the dedicated hacker will find the secret one, the secret path, and try it. But in this case, this is just an academic exercise, so we're just going to show it to you. Like we're trying to make it easy for you to find. Yeah, so it could be, I think it's just a random log. We'll show you this file. Definitely in the 2019 subdirectory tree, it's definitely there. I think there's only one entry. And we'll see this actually when we go through the code walkthrough, we'll see it's like hard coded in the file that they upload. And the secret path is also hard coded, as we'll see. Okay, so we used Lara's credentials to see if we can find the IP address of the thing that's being load balanced. And so that's what that describe instances is. And so I'm going to scroll up to see if I can find the IP address of the site. So that's basically what I'm doing here. I'm scrolling up. And the IP address isn't given, but I actually do have the DNS name. And so this looks like a website. So what I can do is I can copy this thing and I can bring it up in a web browser. And as it turns out, for this particular exercise, I did not ACL this website to just Portland State domains. I actually allowed everybody to access this website, hoping that I wouldn't keep this up very long. So that's what I'm going to do next. I'm going to go directly to this website. I thought I ACLed it. Maybe I didn't. You can get it? Oh, I know why. I'm not doing HTTP:. So yeah, if you are not connecting up to it, it's because by default browsers love to go to the secure version. So yeah, in fact, I ran into this already. I don't know why it didn't that didn't register. So yeah, it's just a static HTML page. There's nothing interesting here. So this is actually closer. I mean, this is probably tongue-in-cheek back when it was written in 2017, I think, or 2018. But like, yeah, who knows? Maybe in 5 years, this will actually be a thing. So we have this now. Let me see here. You could actually get into Linux Lab and then do a wget or a curl of this domain as well. So now we have the secret admin route, and we also have the actual the front end site for this. So I am going to go back and then get the UI. So you can see from this page, I have this as the secret landing page, admin page. Make sure. And it did it to me again. Okay, so yeah, this is the gold star executive user sign up. Run your personalized login command below. And then this is actually an admin command. And then this is a hint. Does it even work? It doesn't work. Okay, so that gets us to the end of the first page. And one of the things you can do is you can do an ls and see, this is command injection. And you're like, oh, look at that. All of these files are here. Oh, that's super secure. Maybe I'll cat index.js. And then you can see this is the JavaScript that's running that thing. You see the secret page and all of the. We'll go through this code in the second part of this class. I'll do the source walkthrough of this thing. So if you have command injection, you can run arbitrary commands on this server. So that's the next part of this this thing. All right. Yeah, we're going to get to the SSH thing. One of the things we need is the IP address of this server. So in the code lab, if you run this command on the server, the ifconfig.me site will basically check the incoming request, the source IP address of the incoming request, and then just echo it back to you. So that's what I'm going to do. I'm going to run the sign up command. And then you can see this is the IP address of the actual backend server that is being used to run this particular site. So that thought that would be interesting for you to see. The next thing I want to show you is that you can actually look. So the way we access machines remotely is through SSH. And much like you set up your GitLab repository, you can set up SSH keys and tilde.ssh/authorized keys. And so that's what I'm going to do next is try and see if I can dump the authorized keys of the Ubuntu user, because I can guess this is a Ubuntu. Well, actually, I think I could just do tilde. I think this should work as well. And it doesn't even matter. I think maybe everybody is using this. All right, that didn't work. So and it looks like someone might have hosed the authorized keys file on this thing. Oh, geez. Yeah, I would just get it from the logs file of the 2019. All right, hang on a second. It may be the case that, yeah. Hang on a second. Okay. All right. I think what's happening is we're getting a bunch of SSH keys added. So hold off. Don't add any more. Let me oh geez. Let me add the one that I'm gonna do first, and let people SSH into it. Right now we've got a whole bunch here. I want to make sure I can get one in that everyone can use. So that will be the next step of the code lab, actually. Let me actually show you where we're at in the code lab. So there's some confusion, like I think people are behind in terms of what we did. So we got to the logs bucket, and then we found the log file that contained that secret path. We did a describe load balancers using the profile to see if we could get the name, the DNS name or the IP address of that load balancer. We connected up to it, and then we went to the secret route. And then we saw that we could run any arbitrary command on this route using this route. And so the next step would be one of the things I would have you do is just run a command on that thing and then do another command that just dumps out the authorized keys. And that just shows you, that you can actually have access to this thing. The next thing, and this is the one thing that I wanted to do ahead of time for you, is to now, because you have access to this, this authorized key file, you can add your own SSH key to it. So that's the next step. But the problem is that the app itself, the JavaScript app that's running this command thing, it's done using Node.js, and it's looking at different characters and decoding them. And one of the characters that it decodes and treats differently is the equal sign. And so you'll see that the equal sign, if you try and just upload a payload with the equal sign in it, you have to actually escape it out. And I didn't really want to have you deal with escaping out the equal sign. So I was like, in the code lab, I ask you to generate an SSH key pair and to continue to do it until you don't get one with an equal sign in it. That's a real ugly kludge, just because I was a little bit lazy in terms of wanting to teach you how to encode the equal sign. And well, it's not really helpful to figure out how to bypass their JavaScript app in this context. You already did that in the web security parts. So that was the idea of this particular part. So what I'm going to do is I'm going to show you how you would have done this on your own. I mean, you could still do this on your own if you would like, but I would ask you to hold off on this until I actually do this for you, and then give you this key back. So what I'm going to do is, as you remember for your GitLab thing, you just generate a key pair. And then you look at the public key for this, because this is the public key is the thing that you're going to upload to the authorized keys file on that server. So we're going to do these two steps on a Linux lab machine. So that's what I'm going to do. So I'm going to do this in the AWS directory. That's SSH key gen -t rsa, and then the file name is foo. And then I'm going to do a cat of foo.pub. It's got the equal sign in it. Let me do that again. Whoops. Uh-oh. This makes me very unhappy. Did I do this with a different? Bits -o bits is equal to, all right. Wow. Maybe I can do 512. Because I don't really care that this thing is secure or not. Wow. Just not very happy with me. I know this thing does give you keys without the equals, but now I don't know what I did to do that. Hang on a second. Let me try it on a different. I mean, I could also do it. Maybe the DSA algorithm is gonna work. Oh, it's because of the name. All right. Well, here's one. Yeah, I think because I think it's because of the account that's generating it. Here's one without an equals. I'm gonna have I gotta work on this code lab actually. So this is the payload that I want. And if I add this to the authorized keys file on the website, then when I you see that this is the private key that is associated with this public key. And so if, so that's what I ended up doing. I did an SSH key gen on this machine. So that's the command you saw before. And then I overwrite it. And then this is the key. the public key, and then this is the private key. Okay, so anyway, I am going to give you the private key. I'm going to put this thing in the Google Doc actually, and then I'm going to add it to that server. So this is going to get added to, where is that credential? I'm going to put this in that credential Google Doc, which is all right. So that is my SSH key that I'm going to add to that file. You can edit a file, copy and paste this thing into it, and then change the permissions on it. And the way you change the permissions on it is to do a chmod. So save this into a file called foo, and then you do a change mod 400 of foo. And then what you're going to do is when you do the SSH, you're going to do an SSH-I of foo, and then Ubuntu at whatever the IP address is. So that's the process that we're going to do now, but it's not going to work until I actually add the public key into that server using the command injection. So that's what I'm going to do next. Where is there I am. Okay, so this is if I run this particular command in that UI, the greater than is the, in Linux, this is the append operator. So I'm going to echo this content and I'm going to append it into the SSH authorized keys file. And so this won't overwrite what's there. It'll just put another entry at the bottom of it. And so what I'm going to do is I'm going to run the echo with the double quotes in here. So echo with the double quotes. And then I'm going to copy and paste the public key that I just generated for foo, and then I just paste it onto the channel or onto the Google Doc. And I think this is it right here. I'm going to make sure I don't send an extra character in here. So I'm going to echo all this and then do a greater than /home ubuntu.sh authorized keys. So I'm going to run that command. And I get no output, but when I do this cat, you should see this thing at the very bottom. So this is at the very bottom of this thing. Whoa. You can see that command actually succeeded, and it doesn't have the equal sign in it. So this, so now what I want you to do is get that SSH key into a file, change the permissions of it, and this would be on a Linux machine, hopefully. You could probably do it on Windows or a Mac, but I think, yeah, the Mac is easy because the Mac has SSH natively. On Windows, you could do Windows WSL. I think you could do it on Cygwin. Cygwin's got an SSH. Yeah, Chrome is always switching you over to HTTPS, so that was a problem. The chmod command is in that Google Doc. Let me show that to you again. Yeah, I put it in here. Yeah, so this thing goes into a file called foo in your local directory, and then you have to change the permissions on the private key. SSH doesn't like if you have your private key wide open for everyone to see, so it will refuse to use it if your permissions are off. And then when you do an SSH, you can say, I want to take on a role of a particular key, and then that's what the -I is. And then you can do a Ubuntu at the IP address of this site. And you just found, with that ifconfig.me curl command, you already know the IP address of this machine. So then the next thing is to get a shell So you're going to be logged in as Ubuntu on this machine. So as soon as you save this off and then you do the SSH, you'll have a shell on this machine. And hopefully this machine can handle how many shells? 50 shells at the same time. I don't know what kind of, well, when we go back into the Terraform files, we can look for the place where it specifies the capacity of the CPU, and then maybe one of you can offer me a suggestion as to how to change the Terraform to support 50 SSH connections going in there at the same time. It might slow down the thing. Oh, it's hanging. Do the SSH from Linux Lab. The SSH is ACLed, I believe. Sorry, I think I do. Let me make sure. Well, first, let me make sure that the key is working. Ah, yes. So someone has tried it. Yeah, I thought I mean, it's already bad enough that anybody can do a remote command thing onto this just using the web UI. But like so if it's hanging, wait, because I think we have 50 people SSHing into that thing. So let me do that. Let me do this directly.
How long is this one going to be up today? Since, maybe we should not all try to SSH in at once.
So let's see here. Yeah, maybe I'll leave it up the rest of the day and then just monitor it. So the permission denied is because of the change mod on your, you have to, oh wait, permission deny public key. No, that's not it. Let me bring up a session that's got that thing in it. So I won't use foo because I already generated this, but this is actually I'll do it from here. So this is the private key. So I'll go through this. So I'll copy this thing. And I'll do this from a Linux Lab machine. So I got rid of both of these things. And then I'm going to edit the file foo to insert the private key. So that's the private key. And then I'm going to quit. And I'm going to do a change mod 400 on this thing. And then if I do a ssh-i of foo, and then I go ubuntu at, and let me go back to this web app, I can run curl if config me again. I already forgot the IP address. So that's the IP address. And then it says, do I want to accept that fingerprint? And so now I have an SSH session on there, and I can see everybody else who's got an SSH. Like, wow, look at all these people. I mean, Kat's going to be like, oh my gosh, someone is attacking this poor server from Linux Lab machines. Okay. So there we are. We have our shell on this particular website that's running this thing. So that's the next step of the lab. Let me go back to the. So now we're here, and then we can do a describe instances because we can describe ourselves and figure out what are we going to do, or what is this thing configured with. So that's what I'm going to do next. I think I can get rid of this. That's already been done, so I don't need it anymore. This I might not need anymore either. Yeah, don't need that one anymore. Okay, so we did this. Now Now we could actually hit the metadata service directly. And one of the things with the metadata service is that it dumps out all of the, so user data is a special thing in the metadata service. It talks about when you instantiate a virtual machine on EC2, the user data says, well, what kind of scripts do you want to run after the thing has been instantiated? Because you instantiate it with some vanilla image, but then you want to customize it to run your application. And that customization is included in the user data part of this thing. So from the, and we could have done this curl via the web UI, the admin UI, but because we have a shell, we can just do this directly from the shell itself. So that's what I'm going to do here. And you can see when I do this curl, this is the script that gets executed when I instantiate the virtual machine that runs this web app. In the startup script, it's basically the installation script that runs after I launch the Linux instance. And you can see it does an apt update. It does a curl to get the Debian stuff in it. And then you can see here, it does this, this Postgres command. And it's got the username and password for an Rds data, well, a Postgres database that's located, and this basically is done through RDS. And so this is game over, right? This could be game over, right? I have this backend database that I have now just discovered because I broke into a website. And this is what we mean by lateral movement and pivoting. I started out on an EC2 instance. Well, I started out on in just access to the log files, and then I found a route onto a EC2 instance and then a hidden admin URL. So I pivoted over to the EC2 instance. And now from the EC2 instance, I can now pivot over to the backend database. And this is called lateral movement in security and pivoting from one resource to the next. So this is actually game over. Like you could actually do this and solve the level because this is where all the secrets are. But I'm having you do the long way. And you can see, oh, it creates this table, and then it inserts into this sensitive information table, this super secret passcode, and this victory string, which is basically the flag that I wanted you to return. And then it basically starts up the application itself that runs that UI, that gold star UI of the website. And this is similar to before. All right, so that's that particular part of the code lab. Hopefully no one has done this. You probably want the AWS CLI on this instance. So if you use a Linux AMI on AWS, it comes with the AWS CLI. But if you're using a stock Ubuntu instance, if you instantiate just Ubuntu in EC2, you say, I just want the vanilla Ubuntu, you actually have to install the AWS CLI manually when that happens. So that's what we're going to do next, unless someone has already beat me to the punch. I'll do an apt update. What? Oh, sudo, and then and somebody has already installed it, so I don't have to do that step. And then I'm going to see, well, what kind of credentials does this thing have? So you remember there are two buckets. There was the log bucket, which we had access to as the Lara profile. But this is a new role that we have, right? Because the Lara profile allowed us to list logs, but like we're actually on an EC2 instance, and typically a different role is attached to the EC2 instance, and that role might have different permissions than the Lara role did. And so we're going to take a look. Well, what does it have access to? Can it do an S3 Ls? And you have to do this on the actual machine, because on this machine, when you do an AWS S3 Ls, it's going to go into the metadata service and then pull the credentials get the access key credentials for this Ec2 role automatically and provide it to the backend S3 service to authenticate. So that's what I'm going to do next. So when I do an AWS S3 Ls, this is being done with the service, the role for the EC2 instance that's running on this thing. And you can see that it's got, again, these are the same buckets you saw before, but the bucket that we couldn't list was this bucket. And if you do list this bucket, you can now see that there's this file db.txt. And let's copy this file. I'm going to copy it somewhere else because everybody's doing this command. So you're all overwriting your db.txt file. I am going to put this, and please don't use this file name. That's my super special location for where I'm putting this file. And when I do this, you can see this message. I love this message. This poor engineer keeps on forgetting the username and password of the database, and then gets a note that says, please save this to your password manager and then delete the file. And of course, poor Thomas, hopefully none of you have this. Yeah, this should be very triggering. This doesn't mean you. And then there's, you saw these credentials in the other, in the user data, but this is it again in a storage bucket. So then the next step is to actually access this thing. Okay, we're almost done with the walkthrough. After this, what I'm going to do is I'm going to let you solve this, go on and solve this for the next 30 minutes, hopefully, and then do the walkthrough. So I'm almost done here. So that is the step we just did. And I don't know why that's a dash. That should be a dot. Sorry about that. I'll have to change that. One of the things you can do is, so now you don't know which database. Actually, you could probably do an ls of. You might even be able to do this to figure out what connections are going to the database. And you can see this is a telltale database port. And then you can see, oh, it's got a database connection to this IP address. So you could actually just do this and then connect up to the database directly with these credentials, if these were the credentials that you were using to connect up to it. But one of the things you can do is so you can see if you have access with this role to RDS, which you should. So this is RDS describe DB instances, or actually you might have, so this has been configured with database access. It won't necessarily be the case that you'll definitely have access, but and when you do this describe instances, you will see as part of this, as you scroll up, you can see the name of it, the domain name of it, 4532. So you would be able to like connect directly up using this particular name, and then 5432, which is basically this command. So when you're looking through this thing, it looks like it's a Postgres database. So, and then you have the username is cgadmin. It doesn't have the password here, but you've just exfiltrated the password multiple ways, actually. So that's what we're doing next. Connecting up to this Postgres database. And the user is cgadmin. And the password is, where did the password go? up here. Oh, shoot, I ran too many commands. Sorry. All right. Purple pony. I should have remembered that, actually. How can he forget those database credentials? PSQL PostgresQL://cgadmin, and then purple pony at, and then from here I do need the RDS domain name. Which is here. :5432, and the database name, which also shows up in the, well, it shows up in here, which is CloudGoat. And this gives you the shell, so the Postgres SQL shell, and it gives you that you're in the CloudGoat table. And then I give you the commands within this to do a describe tables. And you see that this particular table in CloudGoat, there's a single table, sensitive information, and this showed up in the user data as well. And then I can do a select star from sensitive information. And then you can see super secret passcode and then that value. So we saw that in the user data script as well. And this ends the level. Okay, so this is the CloudGoat repository. We talked earlier about how this stuff gets deployed. Just to refresh your memory just a little bit, cloudgoat.py is the main thing. And then it basically, when you invoke the command and you want to create a level, the thing that it does is based on the scenario name, most of the actual code that does the launching is in this directory, core Python commands, and then there's this CloudGoat class that's built in this thing that will take the scenarios as a base directory is the current thing, and then it basically takes the scenario and the arguments and then sends it to the CloudGoat object there. When you go into the core Python commands, this is where you'll see CloudGoat. And as part of CloudGoat, you can see that towards the end of the parse and execute command, you see all these different create commands. You can see that whenever you get the create, then you basically create the scenario based on the name that you give it. And I don't know if I showed this to you before last class, but I have these scripts. So when I do a create, I basically give it a directory name that I want to create the scenario for, and then an AWS profile that has the credentials that I need to do all this deployment. This has basically got an admin credential for everything. So that allows me to do this deployment. This is why you can't deploy CloudGoat on your AWS Educate account, because you need basically admin privileges on the entire AWS account that you're running. And Vocarium is not going to give you that. So, and then I create that scenario based on what's sent into me and using the profile that I send in as well. So this is create scenario here. And if you go down and you go to create scenario, where is that create scenario code? Ah, here it is. You'll see that the create scenario eventually, it does checks a whitelist to make sure you're coming in from an IP address that's been echoed. Eventually, you will see as part of the create scenario a call to Terraform on the instance path. So Terraform is now being called to launch all of the credentials or all of the infrastructure for running the level. And so this is where the directory that you're trying to deploy is then accessed for the Terraform files. And so that's what this command is doing. Okay, and Terraform is a declarative way of specifying the infrastructure that you want to deploy into your cloud project. And so it's really kind of a de facto approach for, I mean, there are some other ways of doing this as well, like YAML files and manifests are also used to specify and then deploy. But Terraform is using its own .tf file, which is their file format. So the next thing I want to show is, okay, the one that we just did was RCE web app. And so if you go into RCE web app, there are two directories, and this is just the way they organized this particular code base. If you have different kinds of Terraform projects, you might deploy them differently. So the Terraform files are underneath this Terraform directory, and then you can see all the different things that are specified declaratively using Terraform files. It also contains assets. So these are static files that you need to actually, so once you instantiate the infrastructure, the assets are the things that you use to populate that infrastructure, maybe the code that you're running. And so that's what these two directories are. One is deploying the infrastructure, one is deploying the thing that runs on the infrastructure. Okay, one of the first things I'm going to show you in the Terraform is the variables, because it has to get all the configuration for not only the project, but for some of the names and the passwords that you're using. And so the profile, this is obtained by the AWS Cloud, or the CloudGoat command, the Python CloudGoat command. You have to specify an AWS profile to use to launch all of this stuff with. And that profile better have administrator access to the entire account. Otherwise, none of this stuff is going to work. So the region. What is also required is this CGID. This is like a, that random string in the CG names. That gets generated by the CloudGoat code in order to get a unique name for every single level that you deploy. And so this is going to be required as well. The whitelist, when you configure CloudGoat, you configure the IP addresses that are allowed to run CloudGoat and deploy infrastructure into your project. This is a security mechanism so that it just restricts who can actually bring up and take down the CloudGoat levels. And this is how I ACLed in the previous step. That's how I ACLed the access to the web server. I made sure that only things in the whitelist were allowed. And the whitelist is basically Portland State's Class B network, 131.252. That's the whitelist in this case. So we have an RDS database that's Postgres. And so we specify that we want to bring up an RDS instance. This is the username that we want to default it with, and then the password. This instantiates an SSH key for us to SSH into any EC2 instance that's instantiated. We don't actually use this at all. It's just configured for us. So those are the variables. I want to next, before I do any other Terraform files, I want to show you the assets. And the assets, there's an application that runs, and that's on the admin site. We'll get to that later. But there's also two files. In the log file bucket, there is that log file that basically leaks the admin route. And that's what this thing is. And you can see this is just hard-coded. This is just a file from 2019. And this is a typical format of a log file that you would use, you would see on AWS. And this is where you can see this thing has been hard coded. The URL that you access is, well, it's at the bottom. Oh, so yeah, some of these things don't have the, you could see it right there. So that's, this thing is not changing. So this is static. every time you launch this level. So this is the magic URL. The other thing is that in the secrets bucket, you'll see that database file that says for the last time, don't save these things, or remember the credentials, but don't save them in a file. So those are the two assets that we will then populate the buckets with. This is the RCE app itself, and you can see it's a pretty simple app. It's got a, in the static directory, it's got a simple index.html, which is what you see when you go to the admin site. And then it's got this special path, this mkja1 thing that basically, if you look, this is a form. So again, this is the form that is on the admin site. And you can see here the action, the post action, when you submit this form, it goes into slash as a post. And then it sends it this, this input. So the whatever it is that you're trying to run. And then you have to supply this magic key so that not anybody can run this thing. You actually have to visit this site in order to get this value that can then be sent to the post for you to execute that command. So you wouldn't just be able to send a post to slash without finding this admin page and have it work. So the actual application itself is in index.js. And this is where the post method on the slash is handled. And you have to make sure that the key that is provided is that secret key I just showed you. And that the path name is slash. And then if so, it's going to parse whatever that code string was as an input and then do an exec on that thing. So that should be a warning for you never to do something like this ever again. And then it gets the output, and this is a template string. So again, template strings and code strings should be red flags for you right now. So this application's got plenty of other issues going on, but then the result comes back. All right, so this gives you a direct command injection. We're not trying to trick you with fancy web app vulnerabilities here. This is just straight up executing a command. Okay, the next thing I want to go, so those are the assets, and we've already seen these assets. So this is how they're created. The next thing I want to go through is the templates that basically specify the infrastructure. So we'll go to S3, and S3 has those two buckets. It's got the log bucket with that one file in it, and it's got the secret bucket with the other file in it. So we'll start at the top. The first thing is a policy object, and this gives you the restriction as to who can access what. And so this allows you to specify access control to the log files, and then the same thing with the secret bucket. You specify the secret bucket resource, and again, this is keyed on that required CGID variable that's unique, that's generated by CloudGoat. So then this gives you the log bucket and so this is the log bucket and the S3 bucket are both declared. There is a key store bucket, but we don't use it. This is a different way of solving the level that we didn't talk about. And then in the log bucket, you basically take the key. So the key is the bucket key. And so the bucket key is basically the path to where you want the asset to go. And so this is the path in the storage bucket that is specified. And then this is what you put in it. So that's the key, the destination key, and then this is the source file, and you see it's in the assets directory in that file. And then this is the bucket that's got the database credentials in it, and then you can see that in that bucket, you see the key that you're going to use is db.txt, and then you're just going to populate it with db.txt from the local file system. Okay, so that's S3. The next thing I want to show you is Iam.tf. So this is the Lara user. The other way to solve this is with this McDuck user, which I'm going to skip because you don't know what McDuck has. And this is the Lara policy. And so you can see it's got to allow on very specific logs, but it doesn't have the allow on the secret bucket. So that's why it was denied. When you did an AWS S3 on this LS on the secret bucket, it's like, no, thank you. This is because it's only been given the S3 permissions on these two, on this particular bucket. You can list all the buckets, that's fine. And you see that when you did the AWS S3 Ls, it actually showed the secret bucket. But when it comes to getting objects and when it comes to listing the contents of objects in a bucket, then it's only ACLed for the logs bucket. Once you get the logs bucket, you can see that there is a permission that allows you to describe the instances and describe the load balancers of a particular project, and that's what these actions are doing in the IAM. I'm going to skip McDuck because McDuck is not going to be used in our, well, it wasn't used in this one. The next thing I want to show you is the Rds database that is running the Postgres SQL. This is the security group that restricts access to this Rds database. And you can see this is restricting access to only these local IP addresses in the project. So you can't directly access the database, even though you know what the username and password are to the database. Because of this security group is filtering on all the IP addresses that aren't local, this is not an externally accessible database. And this is actually good, right? Like you don't want port 5432 to be open. You want all of the accesses to that database to come from internal from the project, and that's how it's done. Okay. This is the description of the instance itself. So you see the port, the Postgres and the version that you want to run. So this is declaratively saying those, and then actually giving the name of the instance that you're deploying as well. And again, this is generated based on a random key that CloudGoat will do. And then here's where you can set the actual what kind of EC2 instance do I want to run here? And so T2 micro is one of those. I think that's all I want to show here. The last thing I want to show is the EC2 declaration. So this is the EC2 role, and you allow any EC2 instance to assume this particular policy role. So this is what gets assigned, and then any EC2 instance can assume this role. What else is here? So this says that I want the EC2 role to be able to look at the RDS infrastructure I have deployed. And this is where describe instances or describe database instances on RDS. This allows you to check out that database that you're trying to hijack or get access to. And this, when I talked about having to do this SSH from Linux Lab, it's because I've enabled the whitelist on the SSH. Now, if I wanted to allow anybody to SSH from anywhere into that EC2 instance, I could have done this, where I allow any sort of IP address as the ingress source. But instead, I say, you know what? Only Portland state addresses are allowed to SSH into this, and so that's what this statement restricts the access to. Okay, the last thing is the EC2 instance that's running all of this stuff. Again, it's a T2 micro. I apply the security groups. And then I basically say, I want you, as part of bringing up this instance, I want you to provision a file that is sourced from my RCE app. So this zip file is a zip of all the contents in the RCE app directory. And I want you to put that in home Ubuntu app.zip. This is going to allow me to install that web server on the EC2 instance. And so this is what the user data, I specify when I bring up this EC2 instance, I specify the user data script that I want to run. And this is what you saw when we did the curl of the metadata service to get the user data. This is doing the installation of this EC2 instance. And as you can see, as part of it, it actually is populating this directory that's got the super secret passcode in it.